So now what we're going to look at is the nitration of benzene, now that we've done the general mechanism for electrophilic substitution. So this is a reaction called nitration, and the mechanism is called electrophilic substitution. The reason I highlight that is because sometimes a question asks for a mechanism name, sometimes it asks for a reaction name. The reagents that we need for this, and this is really important, we need to say concentrated sulfuric acid and concentrated nitric acid. If you write only concentrated in front of one of them, you don't get the mark. I know it sounds really silly to say concentrate sulfuric acid and nitric acid, but no, needs to have concentrated with both. And our conditions for the reaction, we have to have a certain temperature actually. Anything between 20 and 60 is fine, so go for 50 degrees if you want, because really it shouldn't exceed 50, but AQA allow us anything between 20 and 60. Try and avoid learning the range, it's easier just to have a specific temperature. What you might find is that the sulfuric acid technically is kind of a catalyst in this, so does it count as a condition or not? I don't know. But for now, we have to call it our reagent, because this reaction doesn't happen at all, not even slowly, it just doesn't happen unless it's present. So you might be thinking, well, how does this relate to benzene? Previously we said benzene can only react with an electrophile. Electrophile is an electron pair acceptor, something that we should have that's positively charged. At this moment in time, I don't have anything like it. So what we have to do is we have to generate the electrophile. And our electrophile that we need to generate is a nitronium ion. And we have to learn how that nitronium ion has been generated. So what happens is our sulfuric acid, which is concentrated, reacts with the nitric acid, which is also concentrated, and it will form our nitronium ion. It will form an HSO4 minus, and it will also form a water molecule. In this, the sulfuric acid actually acts as an acid, and the nitric acid actually acts as a base. The reason our nitric acid acts as a base is because it accepts a proton, whereas the sulfuric acid, it's actually a proton donor. One of those hydrogen ions is no longer there. It's an HSO4 minus. So it came up in a multiple choice once, I think, where you had to specify what was what. Nitric acid acts as a base, sulfuric acid acts as an acid, simply because our sulfuric acid is stronger, it's diprotic. But that's beyond the point. So now with that, I've generated the electrophile. Mechanism stays exactly as it was before. The ring of delocalized electrons will attack the nitrogen. It attacks the nitrogen because that's what has the positive charge. See here in the equation, I also put the positive charge on the nitrogen. You might find sometimes that it gets written like this. You might find sometimes in an equation it gets written like this. I prefer to write it with the positive on the nitrogen so that I can recall that for my mechanism. If the positive charge doesn't fall on the nitrogen in the mechanism, you don't get that first mark. Now that ring has attacked that nitronium ion, it's no longer as stable. Think about where I'm going to be putting that nitronium ion. It's going to be here, simply because of where I've drawn my horseshoe. I've now got the hydrogen. The electrons from the carbon to hydrogen bond go back into the ring, so that we've substituted out that H plus for our NO2, and I'm left with the H plus. Really, that H plus is taken by the HSO4 minus in order to form an H2SO4, so reforming the sulfuric acid, but we don't need to learn that. M1, M2 is for our intermediate, the exact same as previously, and M3 to show the electrons from the bond going back into the ring to reform the delocalized ring, which makes that nice and stable. So that's all we have for nitration. Just be mindful, sometimes it might ask you, or the question might give you something that looks like this. So it's got something like methyl benzene, and it will tell you that it wants you to form something like this. It will say 4 A, B, C, D, E, F, G, M, N, O. Methyl first. It might say it wants you to form 1 methyl 4 nitrobenzene. If it does ask for that, just think about you have to add the nitronium ion to carbon 4. So when you draw your intermediate, you have to remember the methyl goes there, but the horseshoe would have to be over there because it's carbon 4. So that's just something to be mindful of. And yep, when we've now named it, they are named as nitros. So I could have a nitrobenzene, I could have a dinitrobenzene, I could have a tetranitrobenzene, I could have, for example, a 1, 2, 4, 5 tetranitrobenzene. Can still count and still would be formed in the exact same way. That's all nitration is.